So now I'm ready. Okay, so I'm going to show you a little bit different way to look at elasticity. This has more to do with implicit differentiation, just looking at a formula that's going to look different to you, but it's the same. So we're going to look at this formula right here. And what we were working on earlier today is this formula, negative p times f prime of p over f of p. Well, you will see it written this way in a lot of calculus textbooks as negative dq over dp, which is your derivative part right there. You still have the negative p in there, but then you have over q there. So it's the same thing. So I want to show you why it's the same thing, basically. If you take, and you don't have to write anything down on this, if you take the formula that we learned earlier in class today, I'm just going to show you how you get this same thing anyway. Okay, it goes like this. Basically, what would happen is this piece right here, if I cross that out, that will become dq over dp. That's a derivative anyway. Okay, so that's what that's given to you right there. And then this part right here, f of p, is really the same thing as q. The quantity and price makes a price demand function, so that thing right there becomes q. Okay, so you end up getting the same formula. It's just you have this part, you have the negative, and then you have dq over, that should be dq over dp right there, and then you have the p over q. So we're just going to do a couple of examples with working with the formula in this regard. So basically, all of the problems we did before, the price demand function was related to x and p. Now we're relating q and p, so we're going to use q to represent the quantity. So it's going to be the same thing, but it's just a little bit different notational system on this, okay? So on this particular problem, I'm just going to do two examples on this. And the first thing we're going to do on this one, given this, that's a price demand function where q is quantity and p is price, we're going to go ahead and do dq over dp. Okay, so we got to review how to do this. So remember when we learned how to do a derivative earlier, I know we hadn't been here in a week. So what's the derivative of e to the x? E to the x, hallelujah, everybody remembers that. But what if we had the derivative of e to the 2x? Then what's that? Good. Okay, it's e to the 2x. It's itself times the derivative of the exponent, right? Good. We remembered. Okay, that's the chain rule. So that's going to be the same way. So this is going to be itself. The 100 is just a constant, so you'll have 100 e to the 0.05p times the derivative of the exponent. What's the derivative of the exponent? Negative 0.05. That's the number in front. Okay, so you're applying the chain rule on that. So if you take 100 times 0.05, anytime you multiply by 100, a decimal moves over 2 to the right, so you would end up getting negative 5 times e to the negative 0.05p. Okay, so that's what your derivative is right there. So that's the first thing you want to do. Okay, that's a chain rule for an exponential. It's itself times the derivative of the exponent. Okay. The next part of the problem, I'll kind of number the steps. That's step one. And then step two, just write down this formula. The elasticity is negative dq over dp times p over q. Okay, and we're only going to make two substitutions on this. I'll try to highlight this and show you. So dq over dp is this part right here that we just did. So we're going to plug that in right there. Okay. The other thing we're going to do is we're going to plug in for q. Q is the original problem. We're going to leave the p alone, just like you did earlier in class when we were using that other formula. And when you work it out, you'll have something that cancels that kind of makes this technique kind of nice. Okay, so what you want to do is bring down the negative and then replace dq over dp with negative 5 e to the negative 0.05p. Okay, leave this p where it is. That thing right there stays. And then replace the q with the original problem. So that's what I highlighted in blue. So in blue, you have 100 e to the negative 0.05p like that. Okay, so what you're doing is you do the derivative, and then you just end up plugging in for dq over dp, and then you end up plugging in for q. Okay, are you guys with me on what I've done? Okay, do you see anything that simplifies on this? Is there anything the same? Does anything cancel out or anything? Yeah, this whole thing right here does. See, this whole thing, e to the negative 0.05p, that's the same in the top and bottom of a fraction, so you can cancel that out. Okay, so you can just wipe that out, and then we're going to write what we're left with. So what we're left with is we have a negative negative, so that's a positive 5p over 100, and then you could reduce 5 over 100 by 5, so you would get 1 over 20. So what we would get is you could just get p over 20. Okay, so your elasticity in this problem is p over 20 like that. Okay, all right, so that's how you do that. That looks a little bit, maybe a little bit more confusing, but it's the same thing we did. You know, we did a derivative when you were doing the other formula. We did a derivative here. We're just using Leibniz notation. But what we're doing is, and when we plug in that original function, remember the formula you were using, the original function was in the bottom anyway. So it's the same thing. So what you want to do to finish up the problem is you're supposed to find the elasticity at $25. So you just plug in the 25, you get 25 over 20, and you would get what the elasticity is. That'd be, and I'm just going to use a decimal on that. 25 over 20 is 1.25. Okay, so that's greater than 1, so is it elastic or inelastic? It's elastic, good. Okay, so that's how you work with this different methodology. Don't let it confuse you, it's the same thing. But a lot of times I see economics textbooks where they write this elasticity formula this way. It's pretty common. I like to teach it the first way a little bit better, but it's good to look at it in this regard as well. Okay, any questions? What's that? Well, you can do that either way. I think you're better off at this level of a class to do the first formula. And I don't test over this kind of thing. I do. You'll see a little bit of this on the web work homework for this section, but you won't see this on the test. What you're going to be given is things like x equals maybe something like this. See, I'm going to be giving you x and p in the price demand equation. And if you're given x and p in the price demand equation, that tells you that the way to do the problem is this way. Okay. If I give you something like q equals, I don't know, whatever, say like p to the second, then you want to use the other way. That's how you know. Okay. But p and q are the same thing as p and x. They are the same. That's what I want you to understand. Okay. All right. Any question on what I just did? Yeah. Mm-hmm. No, I'm not sure quite what you're after on that. I just canceled these out. Oh, I know what you're talking about. I do know what you're talking about. You're confusing that with the power rule. So you're kind of thinking, okay, I got x to the third, that's 3x to the second. That's what you're thinking. But on an exponential function, it does not work that way. You do not go through and do that and subtract 1 from the exponent. The rule is for an exponential, remember, derivative of e to the x is e to the x. So that means the derivative of e to any power is itself times the derivative of the exponent. That's where the chain rule comes into play. So that's what you're confused on. Hey, you've been on spring break, okay? All right. Okay. All right, let's go to this next problem then. So one last issue I want to look at on this particular problem. This problem does have a mistake in it. So I want you to make sure that you make one slight change on this. So this right here needs to be a plus sign. I typed that wrong. We would end up with a negative price if I did the problem this way. So that needs to just change that to plus. So you're going to have the equation lnq plus 2lnp plus 0.008p equals 10. Now, we're going to find the elasticity, but notice this equation is not solved for Q. The last problem was solved for Q. And you cannot solve this equation for Q. Well, actually, you could, but you would make the problem an unnecessary mess. So what we can do is we can do implicit differentiation. So in our formula, we're looking for negative dq over dp. Okay, so this will kind of give us an opportunity to review how you do implicit differentiation. So what you're going to do is you're going to put a set of parentheses around both sides, and you're going to do the derivative with respect to p, because that's what the formula tells you to do. So we're going to do the derivative with respect to p of both sides of this equation. Okay, so let's see if we remember how to do this now. Okay, what is the derivative of ln? Do you remember that? ln of q, do you remember what that is? 1 over q, somebody said that? That's right. Okay, so remember what we learned is the derivative of ln x is just 1 over x. Okay, that's the rule we learned. So this is going to be 1 over q, but the variables do not match. So what we have to do is we have to multiply it by dq over dp. And dq over dp is what we're finding in this problem anyway. All right, so we do that. Okay. Okay, let's go to the next stage. What do you think the derivative of 2 ln p is? 2 over p, thank you. It's just 2 times 1 over p. So that's 2 over p. Do the variables p and p match? Yes. If they match, you don't do anything else with it. Okay, so that's done. Okay, what's the derivative of 0.008p? 0.008, good. And the variables match, so you don't do that. Okay, and finally, what's the derivative of 10? Okay, 0. Okay, so you've got your derivative rules there. The thing that you had to pay attention to is when we did the derivative of a q term, the variables didn't match, so we got that. 0.0 what? Oh, this last part's 0.008. Is that what you're saying? Yeah, that part right there, that p shouldn't be there. Derivative of 0.008p is just the number in front. Thank you. Okay, so now what we're going to do is we're going to solve this equation for dq over dp. Okay, so this is kind of what we learned before we were on spring break. Okay, you're going to move this to this side. You're going to move that to this side. You're going to get all of the dq over dp's together. So I'm going to leave 1 over q times dq over dp where it is, but I'm going to move the other things. Now remember, if you move something, what happens to the sign? Changes, right? So it doesn't matter what order you put this in, so I'm just going to say negative 2 over p minus 0.008, like that, okay? And then what I'm going to do from here is I got one more step I have to take. I don't want this q to be here. So I'm going to multiply both sides of this problem by q to get dq over dp by itself. Okay, so what I end up getting is I get dq over dp, and you could distribute the q through there. I don't think you have to. That would be kind of totally up to you. I'm just going to leave it like this. I'm just going to write this as negative 2 over p minus 0.008 times q. Now that is not the elasticity, but that's necessary for finding the elasticity on the problem. Okay? Does that look familiar? That's implicit differentiation. Okay, we worked on that quite a bit earlier, and you'll need to know how to do implicit differentiation for your test. Okay, now that's kind of like step 1. Step 1 is you are finding what the derivative is. okay? So step 2 is we're going to do the elasticity. So the elasticity, we're going to use this formula. It's going to be negative dq over dp times p over q, okay? It's all the same kind of thing. So here's what you do. You're going to plug in, you're going to do 2 substitutions. dq over dp is what we just found, okay? Now what we can do on this is we don't do anything with the q. We just leave that alone. So what you need to do is your elasticity would be negative of this whole thing that we got, which would be negative 2 over p minus 0.008 times q. Okay, you just do that substitution right there. And then the rest of it you write down. You don't do anything with p over q. In fact, the reason you don't substitute for q is because we can't solve this equation for q anyway. Okay, so all I'm doing is I'm doing the result I got in step 1 and plugging it in. Okay, you all with me? Okay, what happens? Does anything cancel? Q does, exactly, good. Okay, so go ahead and wipe them out. That's in the numerator, that's in the denominator. Now we've got our elasticity. Okay, so the way this is going to be now is I'm going to go ahead and carefully distribute that negative through the parentheses. So what I have is positive 2 over p, and then I have positive 0.008 times the p that is left over like that, okay? And then I would go ahead, you can leave it that way, it doesn't matter if you leave it that way. I'm going to go ahead and distribute that p through this, so I get 2 over p times p plus 0.008p. Now that the p's cancel out, so your elasticity is just equal to, it looks like 2 plus 0.008p. That's your elasticity function relating in terms of p. Okay, so that problem certainly is a little bit more difficult than what you were doing earlier today, just because it's got implicit differentiation in it. That's what makes it a little bit more challenging. Okay, any questions? We know what's going on? Can you give me a thumbs up if you do or something? Okay, all right, okay, very good, okay. You guys do seem to remember your derivatives pretty well, so that's good. All right, now, next stage, we've got one more part of the problem and we'll finish this up. So if the elasticity is 2 plus 0.008p, what do I need to do to find the price that maximizes revenue? Set it equal to 1, right? Good, okay, good. So what we do is we set this equal to 1. So we have 2 plus 0.008p is equal to 1, and you solve that equation. That'll give you the price that maximizes revenue. Oh, crap, did I make a mistake? Maybe I shouldn't have changed that sign at the beginning of the problem. I'm going to go ahead and just solve it. Well, it looks like we're going to get a negative price, which I didn't want. So I got 0.008p equals negative 1. Then I would have to divide by 0.008. I think I did this problem in my class Thursday before spring break, and I made the same mistake. For some reason, in my head, I was thinking we had to change that problem to a plus sign, but I guess not. Okay, because you're not going to end up with a negative price. So originally we shouldn't have changed that sign. I just now realize that. So anyway, if you take 1 divided by 0.08, you should get $125 on that. Okay, what happened on that is, and we're not going to redo the problem, what would happen on that is the sign would have worked out if I wouldn't have changed that. So I apologize for that. That minus in the beginning of the problem should have just stayed where it was. Okay, but that's the basic idea on that. Apologize for messing the problem up. It wasn't messed up like I originally thought for some reason. Okay, all right, any questions on that? Okay, so we'll just take that as $125. That's what was intended.